Welcome back to episode 3 of How Flutter Works. In this episode, we'll explore the long-lived state class, which sits attached to the stateful element behind a StatefulWidget, and whose lifecycle methods are where most apps house the intersection between their business logic and their UI logic. There are 5 such lifecycle methods on a state object to know about. They are initState, didChangeDependencies, didUpdateWidget, build, and dispose. By the end of this episode, we'll have a complete lifecycle graph of a state object. The first thing to know about state classes is that their actual constructors are typically unimportant. The idiomatic method to house your initialization code is that first lifecycle method I mentioned, initState. initState is where you should initialize instance resources. Most state classes do something with their initState method because, after all, you only reach for a StatefulWidget so that its backing state object can keep track of some changing data, and initState is where you set that up. This starts our lifecycle graph, which looks like this out of the gate. Next, Flutter asks the state object whether it's new or whether any of its dependencies changed. If either of those are true, it calls another special method, didChangeDependencies. But what does this mean in Flutter, to have a dependency that changed? Flutter has a concept called an inherited widget, which is essentially a widget arbitrarily higher up in the tree that I, a descendant, can depend on and inherit information from. Further, inherited widgets keep a list of any descendants that ask them for information, so that when the inherited widget changes, it can force them all to rebuild. This is how Flutter solves the problem of passing values deep down the widget tree, without forcing every intermediate widget to accept and forward those parameters. In practice, this type of dependency means that somewhere in a state class or stateless widget, you used a magic .of method, like MediaQuery.sizeOf context. Doing this links your widget to that inherited widget, in this case, the inherited MediaQuery widget. Actually, if we want to get technical, it links the elements behind these widgets. To use this method, you override it on your state object, and then perform calculations to be reused later on when Flutter calls the build method. The best part is, those calculations will never be rerun until the MediaQuery size information changes. For more information about this, check out the Decoding Flutter episode on inherited widgets, linked in the show notes below. So that's didChangeDependencies, the second of the 5 critical milestones on a state class you're likely to override. This also brings our lifecycle graph to look like so. Next, if the current rebuild initiated from an ancestor somewhere above this StatefulWidget and state object, then Flutter calls didUpdateWidget and passes in the old widget. This is another method which deserves a special explanation. Whenever you write a StatefulWidget, you ultimately write 2 classes, the StatefulWidget itself and that backing state class. All state instances have access to their current widget via that widget instance variable. But sometimes you need to know not only the current value of a field on that widget, but also whether or not it's changed since the last frame. Say, if you want to animate from the old value to the new. That's where didUpdateWidget comes into play on a state class. Whenever a StatefulWidget rebuilds, which in our case would mean the ancestor of my widget rebuilt, Flutter will call didUpdateWidget on the backing state object so you can detect key changes and take whatever actions are necessary. Note that all of this means Flutter does not call this method on the state object where setState was invoked, because that state object is driving its own changes and its widget didn't update. That brings our lifecycle chart to this, with the addition of didUpdateWidget. Next, Flutter calls the only unconditional method in this render phase, the infamous build method, which brings our lifecycle chart to this. A useful insight from this chart so far is that didChangeDependencies and didUpdateWidget come before build, meaning it's safe to set instance variables in those methods and then use them in build. These methods are also clumped together because some state objects take many laps around this phase. State objects live a good life within Flutter, but all good things must come to an end, and so this state object too shall eventually pass. When an ancestor rebuilds in a way that no longer includes this branch of the widget tree at all, Flutter will call dispose, where final cleanup happens and resources are released. When you write your own state classes, this is where you close any open I/O handles, streams, or animation controllers you may have opened along the way. This completes the life cycle of a state object and brings our chart to this state. Now, the whole point of a state object is to watch data and rebuild when anything changes. And for that, Flutter developers call setState. This adds the state object, again, technically the element holding the state object, to a list, which will be rebuilt for the next frame. Such state objects re-enter their lifecycle at the top of the render phase, optionally calling didChangeDependencies, if appropriate, rebuilding their descendants, which may trigger didUpdateWidget on those descendants, and build all the way down. Some state object calling setState is always what drives a Flutter app forward into the next frame. Interestingly, some state objects only take one lap through their rendering phase and are then immediately disposed. Other state objects take hundreds or thousands of passes through their rendering phase. It all depends on when an ancestor widget rebuilds in a way that disposes of our branch of the widget tree. You call setState by passing in a synchronous closure, which Flutter executes immediately. The convention is, within the closure, to only assign new values to relevant attributes. Any supporting calculations are better left outside the closure to help separate showing your work from the final answer. The reason for wrapping attribute assignments with this setState method is a fun historical anecdote. In the early days of Flutter, developers were forgetting to call the original re-render method after updating attributes on their state classes. After extensive UX research, the team found that this setState API, which accepts a closure, was easier for most developers to remember. One of the trickiest things with declarative UI frameworks, which are so good at rendering the current state, is knowing how to detect changes and render animations or appropriate transitions. In Flutter, you can use these 5 lifecycle methods on the state class to do exactly that. If all of this riveting discussion of the state class hasn't already put you to sleep, you can finish the job by checking out the technical talk, The Lifecycle of a Widget, linked below, which goes into much greater detail. In the next episode, we'll begin exploring how Flutter takes these static configuration objects, widgets, and starts the process of actually rendering stuff to the screen. See you there.